So in most reactions, we have two reactants in order to make some amount of products. So in real life, when you have a reaction, you need certain amounts of both reactants in order for the reaction to take place. Now, in order for the reaction to take place, you are going to end up running out of one of your reactants. In an ideal world, you would have the exact perfect number of both for your reaction to take place, but that's not what always happens. So what we're looking at with limiting and excess reactants is we're trying to figure out which reactant is going to stop the reaction from taking place. So the limiting reactant is the reactant that limits the amount of product that can be formed. The limiting reactant is what stops the reaction. And I have some visuals to help kind of explain what we're talking about here. So the excess reactant is the reactant that is left over after the reaction is complete. There's actually a couple of methods that we can use in order to determine the limiting reactant. I'm going to show you the way that I feel is the most logical and students have had the most success with. There's probably 3 or 4 different ways that you can approach it, depending upon how logical your thinking is. So the first thing we're going to do is we're going to find the grams of product that can be formed from both reactants. So while these problems aren't any longer than the problems we've been working with, we are kind of doubling our work because we're having 2. So in these problems, you'll have 2 givens, and you'll have to do 2 stoichiometry problems. Usually grams are what are requested, however it depends on the problem. The reactant that produces the smallest amount of product is the limiting reactant. Sometimes you will also hear this referred to as limiting reagent. Reagent is another way to talk about a reactant. Sometimes we say we have chemical reagents. They're just synonyms. Don't let the vocabulary get you stuck. The amount of product formed then is the theoretical amount. The excess reactant produces the larger amount, but this amount can never be formed because you're going to run out of the limiting reactant before this much product can be made. Okay, so we're going to visualize this with a more basic reaction to help us kind of see what's happening here. We're going to be looking at hydrogen plus oxygen to make water. Before we start this, you can kind of think about this as making a sandwich. Let's say you're making a turkey sandwich. So on a turkey sandwich, you need bread, you need turkey, and let's say lettuce to keep it simple. If you have 3 slices of bread, you can only make 1 sandwich because each sandwich would require 2 pieces of bread. So that's essentially what we're doing with this. We're just doing it in a more mathematical way. Okay, so in this problem number 9, we're visualizing what we have. So in this case, because both hydrogen and oxygen are diatomics, there's 2 little particles right next to each other. So in this case, we're counting up what we have. So we have 2 moles of hydrogen, and we have 1, 2, 3, 4 moles of oxygen. Now, in real life, a mole is many more particles. We're oversimplifying this to make it easier for us to see what's happening. Okay, so we're representing each particle here as 1 mole. We're trying to figure out how much water we can make. So I've colored in the oxygen red because red is the color when you're using it in a model. So what we're going to do, we're going to do two stoichiometry problems. So I have 4 moles of oxygen. Oh, you know what we need to do? We need our balanced chemical equation. To balance this equation, you'll need a 2 in front of the hydrogen and a 2 in front of the water. So for every 1 mole of oxygen, I'm going to make 2 moles of water. So in stoichiometry, when you're calculating how much of something you're making, you're kind of assuming you have the other reactants. You don't really know that. So in this case, we have to figure out which reactant we can actually make. So in this case, we're going to end up with 8 moles of water. Oops. Now let's calculate with hydrogen. So I have to kind of squeeze it in here. So I have 2 moles of hydrogen, on the bottom, oops, hydrogen, not oxygen, and moles of water. Notice I'm going to the same thing. I'm going to water because I want to compare. Granted, in this case, I only have one product. This is a 2-to-2 ratio, meaning I'm going to make 2 moles of water. Okay, so I have the option, so based on the hydrogen, I could make 2 moles of water. Based on the oxygen, I could make 8 moles of water. So the limiting reactant here is going to end up being the hydrogen. The hydrogen is what's going to stop the reaction. So I'm able to make my hydrogen is blue, 2 moles of water. At this point, I've used up all of my hydrogen. I am completely out of hydrogen at this point. However, I have some oxygen left still. So I used up 1 particle of oxygen, so I have 3 left over. We eventually are going to be calculating how much is left over. Right now, I'm just doing it based off of what we see here. Okay, so in the next example, it's the same reaction, except now we have a different quantity of hydrogen and oxygen. So what we're going to do, we're going to count up how many we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 moles of hydrogen and 4 moles of oxygen. So we're going to do 2 quick stoichiometry problems. We're going to take 12 moles of hydrogen. It's the same mole-to-mole ratio. So moles of hydrogen to moles of water. Based off of our balanced chemical reaction, it's going to be a 2-to-2 reaction. So I'm going to make 12 moles of water. I'm going to do the same calculation now with oxygen. I have 4 moles of oxygen. Moles of oxygen to moles of water. And this is going to be a 2-to-1. So I'm going to be able to make 8 moles of water. Okay. Based on this information, the lesser amount, which in this case is what's produced by oxygen, O2 is going to be my limiting reactant, and H2 is going to be in excess. So we're going to be able to produce 8 moles of water. Now it's going to be kind of hard to draw this in. You have to kind of make them small here. Okay, so my blue dots represent my hydrogen. So then I have 8 waters, and I have to figure out how much hydrogen is left over. So I had 12. I've used, based on counting here, I've used 8 of them. So I'm going to have 4 moles of hydrogen left over.